Hey, Yogesh and others, can you hear me? Okay, I don't see Yogesh there yet. Prabhu. Oh, I see Joe is there. Hi, Joe, can you hear me?
Yep, I forgot about the half-hour offset, so I jumped
on. Okay, all right. So you've been just waiting, probably doing other things.
I figured I'd just stay connected if that's okay.
Yeah. Okay. Yeah. No, that's probably all right. You'll probably hear some of the organizational pangs if you have any issues or panic. But right now, I don't see our main organizer Yogesh connected as yet.
Hello, Ishwan. Just to say the audio is good and clean.
Prabhu, are you back in Bangalore? Or are you...
Not yet back. As you can see, I'm in a garden. Connected and
so this is where is this Madurai? Or
this is close to Kanyakumari, Nagarkoil, and I'm stuck
all the way on the southernmost tip of the country. Yeah, okay,
that's true. Your voice is very feeble.
No, you was talking about me, right? I was muted. Can hear me now, right?
Yes.
Yeah, we can hear you.
So people who will monitor, they will look at the YouTube stream, because keeping both of them open might be interfering with each other, right?
Yeah, what is the arrangement that I wanted to check? Some of us are to.
That's true. I think some of us are to monitor if there are any questions on the YouTube. So you're right that you may have to just sort of look at the YouTube one.
Actually, Zoom allows us to lower the Zoom volume, and
can do that. So is it streaming now? It says that
it is streaming now. I'm looking at that now.
Yes, it is streaming, and it's coming with a slight delay. I think that's what it's supposed to be.
That it does, yeah. There will be a delay.
Yes.
Okay, I thought it's going to start the streaming a bit later when we are sort of ready to go. But that's okay.
So the best will probably be for us to just mute the YouTube and then listen to these things here in the Zoom, and then pick up the things from the YouTube and convey it to the chair.
It may be fine. Just try to see that you have it open in a browser and also the Zoom running, and then one of them has to have a zero volume.
Yes. No, I have muted the YouTube now.
Yeah, Zoom does not have a volume control probably. Yeah, I mean, I can mute myself, but not the streaming.
Yeah.
But the streaming was supposed to start at 3 o'clock, right? Or it's already started?
That's what I thought, but it's streaming.
It's streaming.
Shilkumar, have you started it, or are you just testing something?
Well, I have set up it at 3 p.m. But Hemant told me that you just do it before, so I changed that time to.
Okay.
And there were some problems, sir, so I just sorted out. I need account to start streaming. That's why I just started.
No, okay. Shilkumar, since you are here, I'm looking at the YouTube. it says chat is disabled for this live stream. So is that what we want?
No, that is not what we want.
So then something needs to be done right now.
Yes.
For chat, huh, sir? Let me check.
Yeah, I already got a call saying that Zoom, YouTube chat, they are requesting to enable. Shil Kumar will help.
Yeah, maybe you need to log into the live stream, to the YouTube account and then enable it there. So live chat, it says it's enabled by default.
Hi, Prabhu. Hi, Prabhu.
Hello.
Yeah, Yogesh Wadekar.
Yeah, I was able to post a chat on the YouTube.
Okay, that's good. So
I think he seems to have enabled it. Yeah, and I can see the stream. People need to sign in order to be able to post into via their Google account.
So,
And I had to at least refresh the YouTube page to see the chat. But it's there. I can see Yogesh's message.
Yeah. So 10 people are connected on the YouTube. Shil Kumar, have you made all the organizers as the co-hosts?
No, sir. Only I made you co-host.
So can you make Yashwant, Nirupam, Tirthankar, Prabhu and Dipankar also as co-hosts? There is no limit on the number of co-hosts you can have on Zoom. There can be only one host, but the number of co-hosts is unlimited.
Who else, sir? Nirupam, right?
Nirupam Roy, Yashwant Gupta, Tirthankar Roy Chaudhary and Dipankar Bhattacharya and Prabhu. 5 more people. Dipankar, did you receive the email with the Zoom link that I just sent? You're muted.
I think Nirupam had resent it.
Yeah, Nirupam had resent it, but I also sent it to all the participants.
Yeah, so I use Nirupam's mail to log in. I had not got yours. Let me see if something else has come now.
Yeah.
Yeah, so there is a mail from you saying I received only one email bounce and then a forwarded mail with the poster and things like that.
So it must be an Ayuka specific thing, I hope, because there was no bounce.
Yeah, it is not in the...
I sent a common email to all the participants and I confirmed that you are on that list.
Right.
Dipankar@ayuka.in is there.
But I don't find it in the spam box. I don't find it anywhere.
Yeah.
I don't know where it went.
Yeah.
Prabhu, what happened to him? He also didn't get anything, he said. But,
yeah, I also did not receive. It's quite possible that the Excel sheet did not catch my name. And Raghu here also did not get some names got missed out.
Yeah. So I can see that Joe has joined. Good morning, Joe.
Good morning.
And is our first speaker here, Phil? Not yet. Yeah, I think Phil has just joined.
Yes, good afternoon.
Yes, good morning to you.
Thank you.
So we will start. It's exactly 3 p.m., which is our start time. I think we'll give it a minute and then we'll start. So I think we'll get started with my opening remarks, and then I'll hand over to you, Phil, when I'm done. So welcome to all of you who have joined this special session on Zoom or on YouTube. We've called this session Building the SKA, or from the Indian perspective. This is a special session which is designed to be a prelude to a full day workshop that we are organizing tomorrow, the whole day tomorrow from morning 9:30 onwards. And this one day workshop will discuss in detail the plans for Indian participation in the SKA project. We are here today on a happy occasion where we are commemorating the formation of the SKA observatory. This is really a very big step in the evolution of this project, wherein there is now an intergovernmental treaty organization which has come into force recently, and which will then now be an agreement between all the member countries and will take this project forward over the coming years and decades. Today, we are also going to talk about the preparation of a very detailed 10-year detailed project report for Indian participation in the SKA, which has been submitted to the Indian government a few months ago, and it is currently going through the approval process within the Indian government. Today, we are fortunate to have three distinguished speakers in the session. We have Phil Diamond, who is the first Director General of the SKA Observatory. We also have the Deputy Director General of the SKA Observatory, Joe McMullin, Phil is going to give us a broad overview of the project, while Joe is going to talk more about the technical aspects and the construction plans. The third speaker we have for today is the NCRA Center Director, Professor Yashwant Gupta, who's going to talk about this whole project from the Indian perspective. We will be able to accommodate a few questions at the end of each of these three talks. But I would like to remind all our viewers that we have a dedicated session at the end where we have reserved a considerable amount of time for people to ask questions and for the speakers and others to answer them. So we will have a long dedicated discussion at the end of the call where your questions and clarifications will be taken up. I would like to inform everyone that we will be recording this session so that it can be then reused for people who couldn't make it today. We have today quite a wide audience. I see 46 participants who've already joined, but we expect around 90 or so to eventually join the Zoom call. We also have about 20 people right now watching us live on YouTube. We have an audience that is predominantly consisting of astronomers, including a large number of young people who we hope will be future power users of the SKA. We have also have with us today a number of our industry partners, people who have helped us design the software and design some of the hardware components for the SKA over the last several years. But we have also sent invitations out to other industries and possible future partners. And we hope that some of them are watching us over YouTube. Some of them are registered to this meeting and will be here on Zoom. And so for those of you who are watching over YouTube, we have enabled the comment section on YouTube. So if you have any questions or comments, please go ahead and type them out on the YouTube chat. For those of you who are on Zoom, we will take your questions live. So at the end of each talk, I will ask you to raise your hands and then I'll go one by one and ask you to answer the questions. So that's pretty much it from my side. The prelude is over. Over to you, Phil. Phil Diamond is now going to give us a broad overview of the SKA telescope.
Thank you, Yogesh. Just sharing my screen. Can you see that?
Yes.
Do you see the whole screen or just the?
We see, your presentation in a small window. We're not seeing it full screen. Yeah.
Let me fix that.
I request all participants to stay muted during the talk. Only when you're asking questions, please unmute yourself.
Okay, is that better?
Yeah, this looks good. It's full screen now. Yeah.
Okay. Well, thank you to Yogesh and to Yashwant for inviting me to come and give this talk. I do apologize for not being there in person. As many of you know, I have visited India on many occasions, and it's sad that the current world situation doesn't allow that this time. But I do look forward to future visits. So what I want to do in the next 20 odd minutes, allowing time for questions, is to bring you up to date with the current situation with regard to the SKA. As Yogesh has just indicated, we are a project in significant and very positive transition at the moment. So first of all, can you see that change? I just did want to congratulate Ashwin here on his fantastic achievement of the third time he'd done 5 wickets and 100 runs in a test match the other day. And congratulations to India for comprehensively beating England. I should point out it's now 1-1 in the series. Looking forward to the future games. And I know Joe McMullin will be totally confused as to what this is all about. But I'm sure my Indian colleagues appreciate it. So, SKA, well, I'll be very brief on these first few slides. We're a global collaboration. We're building and operating the next generation radio astronomy observatory. And as Yogesh has just indicated, we now have, it's entered into force an intergovernmental organization governed by a treaty. So in the future, from now on, we refer to the project as the SKA Observatory, or SKAO. We have 16 countries, and of course, we're going to build 2 telescopes, describe them briefly in a moment, with a global headquarters in the UK. And we have 2 data processing centers, or will have 2 data processing centers, one in Perth and one in Cape Town. Plus, as you in India are fully aware, a global network of regional centers to deliver science-ready data. I'll talk about the overall anticipated cost of the project in a moment, but the headline number is just under 2 billion euros for the first 10 years. This map shows the 16 partner countries in the light blue there. Not all of them are full members yet of the treaty organization. I'll talk to that in a moment. But we run under the mantra of 1 observatory, 2 telescopes, and 3 continents, because it is our intent and all our planning is focused on running the whole observatory as an integrated operation. So we work very closely with our partners around the world for the construction activities, and with CSIRO and SORAO, the South African Radio Astronomy Observatory, for the operational aspects. Just to put SKA in context, this is a very nice picture showing what 21st century astronomy will look like. And for you younger people on the call, I do envy you that you will have all of these facilities available for you to do your research. It's a fantastic set of mega science facilities, all the way from the radio to the gamma ray, with of course the SKA providing the radio cornerstone of all of this. You know what we're building: 2 telescopes, SKA low frequency, 50 to 350 megahertz in Western Australia, and SKA mid in the Karoo, going up to 15 gigahertz. I won't say anything more about this. You're all very familiar with what it is that we're building. Just to emphasize that we will be incorporating Meerkat, the operational 64 element array. So in a sense, about a third of the telescope already exists in South Africa. We'll be building out from Meerkat. And then we have grand plans for a second phase of the project. This summarizes the total cost, which is, as I've indicated, just under 2 billion euros, 2020 euros. You see in the bottom left corner there. This is made up of the estimated capital cost of construction for all of the hardware, the construction support budget, which is the project managers, system engineers, and all their associated costs, travel, etc., to support the construction activity. And then about 660 million euros for the operational aspects, which starts right now. So it's paying the salaries of people at the observatory, but will increasingly then cover the cost of operation as the array is built out. And we do intend to have a well-funded observatory development program. No observatory, no well-founded observatory can operate effectively without a development program. It rapidly will fade away from being world-class. And then the diagram below shows the estimated spend profile for construction and the other activities. And that's for the first 10 years. Of course, we'll have to carry on with the operational and hopefully there's 2 construction funds after that. And the headquarters are in that very nice new building sitting at the feet of the Lovell telescope there. And that's actually looking out of the window pretty much what today looks like in the UK. Although I'm at home, of course, not at the observatory. We have nobody on site at the moment. This is our very nice council chamber, which we hope to be reoccupying for council meetings in the coming months. So there will be plenty of talks later in this meeting on the science drivers. So I just put this up there as the summary of the key science drivers which guide the requirements for the observatory. Joe will talk a little bit more about those requirements in a moment. So the current status. These are the key recent milestones that occurred last year. The mixture of the treaty being ratified, successful system critical design review, successful operations review, external cost audit, business enabling review, etc., etc. And then in September, the SKA board endorsed the SKA1 construction proposal and the observatory establishment and delivery plan. And that was a key milestone, building on a decade of work by many people, including the Indian community, which Yashwant will describe shortly. Then in December, we achieved the minimum number of ratifications required for the observatory to enter into force. There was a 30-day notification period, but on January the 15th, that happened. And then the 4th of February, we had the first meeting of the SKA Council. So I regard actually the 4th of February as the date of birth of the SKA Observatory. And there was some very nice press. So we had our own website, the BBC put something up, Science. And I have noticed from my Google News feed that there were various articles in the Indian press as well, which was gratifying to see. These are the key documents I've mentioned: the construction proposal, the observatory establishment and delivery plan, and prospectus. These will be actually electronically available to the broad community fairly soon. So first council meeting. We have 6 formal members. These are the countries that have ratified the treaty. And we had 10 observers. And India is in the so-called observer list at the moment because ratification and approval processes are proceeding in India, as you know well. So we expect China and Sweden to become full members in the relatively near future. Canadian colleagues have a proposal into government. Process is proceeding in India. France, Germany, and Spain have applied to join the SKA observatory, and discussions are in process there. Switzerland have stated that their national processes don't allow them to make a decision until 2022, 2023, but we are setting up an interim arrangement with the Swiss. And South Korea and Japan are at an earlier stage in the process, so they will come a little later. There were key decisions made at this first council meeting, a lot of decisions, but these had been prepared through an extensive series of almost 20 meetings beforehand. So Catherine Sisarski was appointed as the first chair of council, Gan du Toit from South Africa as the vice chair, Colin Vincent from the UK as the co-chair of the Finance Committee, which will have a crucial role in the procurement stage for SKA. Simon Berry from my office is seconded to the council until May. Reason for that will become clear in a moment because we have not yet transitioned all the staff to the council. And I was honoured and humbled to be appointed as the first Director General of the Observatory. So various other key decisions occurred. The committee structure was approved. The various, what we call Tier 2, the high-level policies, intellectual property, operations, access, and procurement were done. The working documents, procurement manual, in-kind framework, fair work return framework were approved. Huge amount of work went into those. What we call the initial funding schedule, this is the minimum funding needed to pay staff for the first 2 years. That was approved. And the various regulations and policies for staff, the things that you need to make an organization like this operational, they were all approved. So SKAO will become an operational entity from the 1st of May. That is the date on which all of the staff will transfer from the current company, the organization, to the observatory. All of the assets will transfer. And so right now it's a sort of, I describe it as an empty vessel, but it will become a fully operational entity from the 1st of May, 2021. And we will then begin the process of shutting down the current company, which will no longer be required. Other key decisions, Council endorsed the construction proposal and the OEDP, the Establishment and Delivery Plan, endorsed conditional allocations of work for construction. Again, a huge amount of work went into that. And they approved the management towards a staged delivery of the baseline design. So Joe will talk about this in a moment. But basically what this means is at the point of approval of construction, we won't have all of the countries as members. So there'll be a process where we have to manage the procurement and delivery as that money flows into the observatory. So we are on track for a decision to approve construction with the start of construction activities on the 1st of July this year. I'm not saying I'm not guaranteeing we will meet that, but that is our intent, and we're on track for that. The council also approved a new logo and the evolution of the brand. I can hear an echo. Is it Jitendra has a microphone on? This slide shows the key project milestones, which Joe will talk to, but as you see there, start of construction T0 is 1st of July, various milestones through the years with a projected end of construction in July 2029. Now there is 18 months of schedule contingency built into that, and fingers crossed, we'll be able to formally end construction earlier, but this I think is a realistic schedule. So more from Joe in a moment. This is what the functional structure of the observatory will look like with the global headquarters and then various centers and the telescopes in both Australia and South Africa. And I've got a little bit on each of these at the moment. So you see there the engineering operations centers. These are the base, there would be two, one in each country, a base for engineering operations and on-site activities, such as maintenance and repair. And these will be relatively close. Well, relatively close. In Australia, it's 350 kilometers from the site in the town of Geraldton, a little bit closer in South Africa. Then you see the science operations centers. These will be respectively in Perth and in Cape Town. And also the science processing centers, the high performance computing centers. These also will be in Perth and Cape Town. And we've gone quite far in understanding where these will be. So in Australia, the Science Operations Centre will be in this existing building, which is owned by CSIRO in Perth. It's a large building, so we will occupy just a relatively small part of that. The Science Processing Centre will be in the Pawsey Centre, which is just a few hundred meters from the ARC building. These are the architectural concept designs for the Engineering Operations Centre in Geraldton, which will be right next to the current ASCAP equivalent. There's spare land next to that building. This is the Buladi accommodation facility. At the moment, there are what the Australians call dongas. These are converted trailers. They're actually relatively comfortable, but they're not a long-term solution. So we will build a new lodge out at Buladi, close to where the telescope is, to accommodate people locally. You will notice there's a pool here. I should say it's not a swimming pool. That's a reserve of water to fight fire if it ever happens, and it just may coincidentally be used by humans to relax at the end of the day. In South Africa, you see here a map of the area near Cape Town, and SKA will be building a new building at the location indicated there, so-called Ithemba Labs. This is an aerial view, and you can see outlined in this orangey yellow color the piece of land where the new SKA building will be located. So it will be put in this particular place here. And I'll tell you what will happen with the rest of that land in a moment. Another thing we're progressing towards is we're preparing a request for proposals to deliver power for the telescopes and in fact also the buildings and the supercomputers. In South Africa, there is grid power, but it's insufficient capacity, and there's poor infrastructure and escalating costs. So we are pursuing a solar photovoltaic solution. in South Africa. In Australia, at the site, there is no grid power, so we have to have an independent power system there. And again, we're pursuing a photovoltaic solution. In Perth, of course, there is a plentiful and reliable grid system, but we will consider purchasing renewable supplies over the grid. So we are moving forward on this request for proposal, and that should be issued shortly. This, of course, is the existing photovoltaic battery with a diesel backup system that exists to provide power for ASCAP and MWA. We need something about 3 times the size of that for SKA alone. But it already demonstrates that this works, and the infrastructure is there. So we'll be proceeding on that basis. And then coming back to the ITHEMBA labs, it is our intent to put a photovoltaic power station here to provide the necessary power for the supercomputer and, of course, the building. Data is a huge issue for SKA, handling the data, and of course the numbers are somewhat frightening. And for the SKA, the operational model is different than for traditional telescopes such as the GMRT, because the supercomputer becomes a part of the telescope. It will process and calibrate the data on the fly. And so it becomes a schedulable resource of the telescope itself. And this is one of the primary reasons why we need the SKA regional centers as a scientific interface to the SKA data. So from each telescope will be, when they're fully operational, will be transmitting of the order of 350 petabytes per year. That will go over undersea fiber cables to the various regional centers. And this is just an illustration of where such regional centers might exist. These require 100 gigabit per second connections. And work is underway planning for this regional center network. We have 6 working groups looking at various aspects of the architecture. And we're just in the process of recruiting an SKA regional center architect within the observatory to oversee the design activity for the network. Just moving on, Science Data Challenge. The second Science Data Challenge we've issued is underway. This is a particularly large one with a simulated, actually 1 terabyte cube of the sky with of the order of 10 to the 7 continuum sources and 10 to the 6 simulated neutral hydrogen galaxies within that cube. So you can see the properties of the cube there. This has now been, the data challenge has been issued. What's very pleasing is we've had 40 teams from around the world they're participating in the data challenge, and we have 8 supercomputing centers who are participating as well and giving time to the teams in the data challenge. So at the moment, we're just coming to the end of matching teams with resources. We expect the whole thing will be complete in July. And we will be running subsequent data challenges as well. But this has been a very successful process. And then finally, just want to advertise that we will be having a virtual science conference in the middle of March. We're already heavily oversubscribed for the talks, and the scientific organizing committee are going through selecting the talks and identifying which contributions will be given as posters. We're using the on-air system, which has been used successfully at, for example, the European Astronomical Society. And registration is open, and I would encourage people to register. We've kept the cost very low. I think it's £40, and that's really just to cover the costs of the on-air system. But I would encourage people to participate in the conference. So I hope I've convinced you that 2020 has been a year to remember for many reasons in the SKA. Of course, you know, the pandemic has made it a year that we will want to forget in the future. But what it has demonstrated is that basic science is key, absolutely key to our civilization, to our health and our welfare. And I think governments recognize that. And let's hope that 2021 is a year to celebrate the birth of the observatory and the start of construction. So thank you very much. I'll stop sharing. Over to you, Yogesh.
Yes, thank you very much, Phil, for an excellent update and introduction to the SKA telescope and observatory. We will now we're now open for taking questions and comments. So the participants who who are on the Zoom call and would like to ask a question, please raise your hand using the raise hand facility on the Zoom, and then we'll take questions one by one. And those on the YouTube, please type in your questions into the chat, and then we have people on hand to sort of collate those questions, and we'll take them once we are done with the Zoom questions.
Seems I was crystal clear, Yogesh.
Yes.
No worries.
Let's give it a minute, and because there is I believe a delay on the YouTube side. So if there are people who want to ask some question there, we'll give them a second.
So I see there is a question on the chat line, the Zoom chat line, Yogesh.
Yes, so let's pick that up. When will the first set of data be gathered? Which year he wants to know exactly.
Yeah, so as I indicated, you know, the full operation will come towards the end of this decade. But there will obviously, once we have a significant number of dishes and systems, software, digital signal processing systems, etc., in place, we will begin the commissioning process, the science verification process, working up to shared risk observations and things like that. And I would imagine the very earliest dates that would start would be 2025, 26, something like that. When we open it up to shared risk observations with the community, maybe around 2026, something like that. And these will be necessarily small scale observations, but with real SKA data at that time. No guarantee of success, of course, because we'll still be in the process of commissioning and debugging the system. I hope that answers the question from Kiran.
Well, what about the start date for full operations?
Well, we anticipate that will be around 2029, 2030, when we'll be able to really start the big key science programs, the big surveys. But PI-led projects may well happen a little before that. It all depends on the construction team's progress, which Joe will talk to you about in a minute. So we have a plan, of course, but between now and then, the telescope has to be built and commissioned.
I don't see any questions on the YouTube chat. Nirupam, can you confirm that there are no questions?
Yeah, no questions yet on the YouTube.
There is another one from
There is
Prabhu.
another on the.
There's another one from Prabhu. Phil, you want to take that?
Yeah. So Prabhu asks, are we still open to for new member countries to join the SKA? And the answer is absolutely yes. We don't yet have all of the funds that we need. So any avenue, any country that is interested, we're very willing to talk to them. And we have had conversations at the scientific level with 2 or 3 other countries, other than those that I mentioned in my talk. So yes, we're very much open to new partners joining, and I do anticipate over the years that this will happen. We're also, of course, talking to the existing members and observers about increased funds with time. And I'm confident that such things will happen. The governments are not going to invest money in a facility like the SKA and not funded appropriately. So we're exploring every route.
Yeah.
Yogesh, sorry, since I am a co-host, I cannot raise my hand. So can I ask a question?
Go ahead.
Yeah. Phil, has there been any decision or updates on how the telescope time will be distributed between different member countries, the science time?
So the access policy, which is one of those very high-level policies that I mentioned had been approved, basically it has a high-level principle that time will be allocated in proportion to the contribution made to the construction and operations. Now, actually implementing something like that is much more complex than just making that statement, because as we all know, the composition of science teams, especially for big surveys, will necessarily be multinational. So how one actually develops the algorithm to work out retrospectively, and it will be retrospectively, how that time is allocated against the pro rata expectation. That's something that the science team are working on the most efficient way to actually do that. I do note that ALMA, which has a smaller number of formal participants, Europe, North America, and East Asia, the approach they've adopted is to base it just on the PIs. I'm not sure we can quite do that for SKA since we have many more partners, but it's something to be worked through. But it's also something that we won't allocate a specific block of time to a country. We will accept proposals and judge them on their scientific merit. And then after, say, a few years of observing, we'll look back and say, well, country X is significantly underrepresented in the science outputs, and we'll look to see what we can do to assist the scientists from that country.
Thanks, Phil. Thank you.
Yeah. I see Nirupam has raised his hand. Nirupam, please go ahead.
Phil, I have a quick question. So is either the timeline or the projected budget affected by the pandemic in any significant way, or is it more or less at the same ballpark?
Well, I've given what our expectations are, but of course the pandemic is influencing things. We've largely been working from home for a good fraction of the last 12 months. Nevertheless, the team have done an amazing job in putting together the proposals and actually conducting the reviews. So I don't anticipate that the start of the construction activities is going to be significantly delayed, if at all. But what might impact it, and Joe may comment on this a little later, is if we are significantly limited in international travel, because one can't construct a project like SKA without traveling. That may have an impact. That may slow us down somewhat. But we've looked at that, but it's such an unpredictable thing that we haven't really judged the impact. We've just registered it as a risk. And of course, on the funding side, well, look, it would be unrealistic for me to say that the pandemic has not had an impact. What is pleasing is it hasn't had a major impact, but some countries are saying, look, we may not be able to, we will be able to deliver the full funding we promised, but it could be that the funding profile, our ability to deliver it as quickly as you want, may be impacted. But to be honest, we haven't had a definitive statement from any country on that front. And we're in discussion with them all. So fingers crossed. So far, nothing significant or particularly worrying on that front.
Yeah, there are a couple new questions on the chat. There is a question from Dipankar who's asking, how will the work assignment, particularly the in-kind contribution, be decided for countries that join later?
Yeah, that in itself is a challenge, because I'm sure, as Joe will say, he needs to know who is doing the work at the start of the construction activity for the major constructions. We can't, there are some possibilities for later down the line. There are possibilities, for example, to add capabilities to the SKA, bands 3 and bands 4 on SKA mid, and not part of the design baseline. That we always anticipated they would come later. So we do have to be a little bit creative in new countries coming in, and it could be that if a country joins quite late in the process, they will have to, that benefit will be in the science return. And that happens, for example, at ESO. Just as an example, the UK joined ESO many years after it was first created, and they effectively paid a joining fee and then an annual operations contribution, but they get to be engaged in instrument design and, of course, heavily within the ELT, which is a new project. So what we have to hold out is the hope, is the expectation that new countries will have a significant role in phase 2 of the SKA.
Yes, that's right. We have one more question, which is about interference. Has there been any effort in measuring the interference at regular time intervals in Australia and South Africa? I think he's referring to RFI. Yes,
and this is something, of course, that we're heavily engaged in. We have a spectrum management team, some very competent engineers. We're working with Soreo and CSIRO, who, of course, have telescopes operating on the ground. So we know what that interference environment looks like. Both sites are protected by national regulation, significantly strong regulation. But of course, one of the challenges is these mega constellations which are being launched right now. We're actively working with the companies that are launching these to minimize the interference on the sites. So it's the radio astronomers, as people at the GMRT and UT will know, have been living with RFI for years. We have various mitigation techniques, various avoidance techniques, but it's a continual battle, and it will continue to be for the lifetime of SKA and radio astronomy. So we have mitigation processes that we're pursuing.
Yes. We have one question on the YouTube channel from an undergraduate student, and he wants to know, Himadri Saha wants to know, what are the opportunities for an undergraduate student to be involved with the SKA? This is an undergraduate who's seriously interested in research.
Yes, well, so we at SKA right now, we have a small science team and a significant engineering team, and it will be growing. But our primary mission is to construct and operate the SKA. Of course, as part of that, a strategic element of that is to work with our partners around the world to ensure that there's an immensely strong scientific and engineering community that uses the SKA and that supports the SKA. So I would say to an undergraduate, the primary route into this is first of all, if you're in science, pursue a PhD, or on the engineering side, get into creative and innovative engineering in areas that the SKA or astronomy generally needs. And we will be hiring a lot. We're going to be, we're about 120 people right now. We'll need close to 500 at the peak of the construction program, and so 440, I think, in the long-term operational program. So there will be opportunities. We will at some point be running a postdoctoral program for researchers. So I think there are plenty of opportunities there around the world, and with the interest of governments in SKA, the opportunities, I think, are growing in universities and research organizations.
I'd just like to add here that in our funding proposal, noting the fact that this telescope will be used in the 2030s onwards, essentially, we have proposed a significant budget for building up the human resources, the skilled engineers and scientists who will be the users in the future. So we have designed special programs for undergraduate students, for PhD students, postdocs, and even the general public. So we will have in tomorrow's workshop between 2 and 2:30, we have a small session on the outreach activities, which are primarily to the public, but also towards undergraduates. So you're encouraged to join the YouTube feed at that time and find out more. There's one last question which we can take, which is from Prabhu. Prabhu wants to know, could you comment on what is likely to be the phase 2 of the SKA?
Yeah, so what is pleasing is that various of our member governments still have the goal of pursuing phase 2, which I think is excellent. But before we plan deeply on that front, I think we have to demonstrate that we can build and operate phase 1. So I think we're probably a few years away from serious engagement with governments on phase 2.
Right. Yeah, I think it's still something that has not been properly defined.
No, it's the science case is there. The science case, we did the science case for the full SKA. Of course, science case evolves. But I think this is something for my successor.
Yes. Okay, so I think we have addressed all the questions that have come in. And I think we've sort of exhausted the time that we had reserved for this talk. So we'll move on to our next speaker, Joe McMullin, the Deputy Director General of the SKA Observatory, who's going to come in and tell us more about the technical aspects and the construction plans. Over to you, Joe.
Thanks very much. Are the slides showing properly?
Yes, we can see it full screen. It's all good.
All right. Okay, perfect. Okay, so following from Phil's discussion, I want to talk today a bit more about the project and essentially following up a little bit about how the design in particular has evolved over the long development period. I will talk about some of the technical aspects, although I look around at the attendance and many of you have strongly contributed to that. And so it'll be good to use that perspective in how we're planning the construction. And so let me just kind of kick ahead. And I want to show a slide that Phil also had up, but I just wanted to talk about it a little bit because the SKA, like other large telescope facilities, is ultimately driven by these questions across a broad range of astrophysical frontiers. And so there was this period of scientific consultation, and it led to a list of science drivers. And those were then used to kind of refine and develop the science use cases for the SKA. And the list here, the testing general relativity, cradle of life, cosmic magnetism, those are just some of the most compelling areas where we think we have an opportunity to drive further the understanding once we have the right instruments. And so this is a few diagrams that to kind of talk through. On the left-hand side, it's a representation of some of those key science drivers, kind of along the top, cradle of life again that you can see, cosmology, et cetera. And it gives you, again, that sense of the breadth of science cases we anticipate the SKA can impact. And if I had to summarize the goal of the SKA overall, it's simply to kind of detect, resolve fundamental astrophysical processes at their intrinsic scales, spatially, spectrally, temporally, throughout the universe. So just that's all we're trying to achieve. So it is a very broad ambition. And so how do you distill that ambition into something that you can actually build? And so those science goals ultimately drive on an engineering design. And so maybe taking the cradle of life, which is kind of an area near and dear to my own heart, that area, it needs excellent continuum imaging sensitivity in order to see gaps maybe in the protoplanetary systems. You need broad spectral coverage to be able to disentangle maybe coupled spectral energy distributions from the different physical processes. You need excellent spectral sensitivity to detect maybe some of the complex prebiotic molecules. And you need spectral resolution maybe to see the motions of the gases, the infall and the outflows, to piece together the real portrait of the evolution. How do these systems actually come together? And then underpinning a lot of that, and it's a key driver in a lot of the science cases, is the influence of magnetic fields on those processes. And so the polarimetric aspect of that. And so you can do this across, and you can see these drivers point to a specific set of technical specifications that are in common. And so now if I skip over onto the right-hand side, and I recognize it's a bit challenging to read, but the broad features are really what I'm kind of trying to convey. And what that's showing is along the bottom on the x-axis, if you will, is the frequency coverage. And along the y-axis is this range of science areas that we think we can influence. And you can see the green bar along the top, hopefully you can see my cursor, is showing the low frequency coverage, and then the red bars are illustrating the receiver bands within mid. And so it kind of shows you how this, the influence basically of the science on the determined frequency range for the observatory was established, how we begin to put together the overall design into something that actually fits what we really need. And so you generate the set of technical requirements, but looking on the left, you have this lovely triangle of scope, cost, and time, and these are practical considerations that are in play. And of course, an overarching driver on quality. And quality is especially important to us because we're producing so many similar components in the architecture of an array and of an interferometer. And so looking on the right, trying to capture the interplay of the drivers with the realization. And so the observatory, and this is a key feature of the SKA, is it's not an experiment. It doesn't have a pared down set of requirements to execute an experiment. It has a set of science frontiers to explore, but there is also this unknown aspect and the emergence of things over time. And so a broad set of capabilities are really what you're looking for. And that's what we're trying to kind of balance over a rather long lifetime. And so, the configurations, as an example, there you're trading between, infrastructure costs and the need for the science cases, the UV coverage, the beam characteristics, and the imaging qualities. And then similarly for the antennas for both facilities, there are key drivers that set them up, either the bandwidth ratio or the unobstructed aperture that drive on specific design details. But fundamentally, the question is, can you build it? Can you deploy it? And can you operate it? Does it fit within the environments that we're building? These are remote and challenging areas, quite distinct from the lab setups that we begin the testing. And given the expansiveness, broad over a large range, distributed over tens of kilometers, and the remoteness, the quality attributes again really come into play. And so this is sort of the design strategy that I think we've adopted, supported by many of you, to get to the point where we are today. And another aspect, of course, is that we're aided by a lot of precursors who are maybe not architecturally identical, but they've paved the way. They've illustrated technologies, they've illustrated techniques that can be used, and that has supported the design path that we've taken. And so you can see so many of these, but along the top hand, these are the operating instruments that are really direct precursors from ASCAP and in Australia, and MWA in Australia, and Meerkat and Hera in South Africa. These have really illustrated a lot that we've learned from, try to take some of those lessons and integrate them in that design process, our own prototyping process, to come up with the final design. And this is just a kind of the summary, the history, if you will. It's taken us a long time to get here, and this shows the commitment of literally hundreds of scientists and engineers as represented in each of the member country institutions, driving forward and going through that process of elaborating on a design, trying to qualify it, and then us trying to put all of that together in the end. And so maybe just to kind of, once you do have the sets of requirements, the way we really broke things up was through the help of these different institutions, and different consortia, collections of these institutions came together to deliver on aspects of the overall observatory, subsystems of those that could be captured, tested, and then handed over, and then we could kind of assemble that as the overall. And so the worry that we had, of course, and that did take some time, is that it's a little bit restricted or narrow in the sense of how does all of this connect together. And so on the right-hand side is kind of illustrating the fact that we went through a further process where we were able to step back from the individual components and look holistically at the observatory as a system, challenging on those designs and ensuring that there weren't gaps, that all the interfaces actually worked out. And this process took well over a year to come through. And then going through a standard, system level critical design review process, panels of experts coming in who have their own scars from their own observatories to polish and improve on things, developing and finalizing that design, but also finalizing on a lot of those programmatic aspects, making sure that it all holds together and it's something that we can deliver to our community in a relatively predictable way to meet their expectations. And so this is one, Phil also showed this slide. I'm kind of emphasizing maybe a little different aspect of it. So this is, the summary architecture of the observatory overall. And a lot of what the construction project is, it can be summarized in the green. These areas are really what we're building with the SKA1, and these sort of blue or purplish boxes that Phil was emphasizing. Those are deliveries provided by the host countries, but really critical to the overall function and operation of the observatory. And the black lines kind of connecting things are showing sort of the data flow, and talk a little bit more about that. And the red lines just showing the overall coordination with the headquarters and the host country facilities on the ground overall. And so this then is good. It just shows what the facilities will look like. On the top is the SKA1 low in Western Australia. You can kind of see the location of the site, about 600 kilometers northeast of Perth, for reference. With baselines up to about 65 kilometers. And the facility is operating across this continuous frequency range from 50 to about 350 megahertz. And the right-hand side shows what that array physically looks like, maybe more distinct, very distinct from MID, where we're using these log periodic antennas, which are coupling many dipole antenna elements together in a ladder to achieve that broad bandwidth. That was a key driver. These are then combined in these circular arrays that we call them the stations, and 256 antennas in a particular station. You can see these are an older prototype where we had some different foundations for the individual antenna elements, and then 512 of these individual stations to kind of make up the overarching sensitivity and capture the capabilities that are needed for the science cases. And so it's a long wingspan, if you will, of fiber and cable across the deserts. There are kind of 37 individual buildings, 36 small ones and one big one that are there, and all of the infrastructure associated with that. So really, the thing that I think we forget sometimes in astronomy is we're not building observatories. We're really building small cities that have to have all of that functionality, all of the support to be operational over that period. And so then on the bottom, of course, is the MID facility in the Karoo region of South Africa, and that's about 450 kilometers northeast of Cape Town. And it shows the location of the array. And this one is distributed over even a longer maximum baseline, about 150 kilometers. And this one now is operating from 350 megahertz, picking up from low, all the way up to about 15.4 gigahertz. Right now, I should point out, we have some of the frequency bands that are designed into the system, but are not provided in the first delivery of SKA1. Those are bands 3 and 4 and 5C in particular. And on the right-hand side, you can then see the individual antennas, kind of those structures being put up. So it's really composed of 133 of these 15-meter dishes, coupled with the 64 dishes that already exist. These are 13.5-meter dishes from the Meerkat Observatory, making about 200 dishes over that full extent. Whoops, sorry. And so this then is showing, again, a little bit more detail. So graphical representations of low on the left and mid on the right again. And so just allowing us to zoom in on some of the details. So the left-hand side showing the sort of the 3 spiral arm distribution of the stations, and then zooming in to see the clusters of the stations and how the core is arranged. You can see the collections of 6 stations per cluster, and then looking at an individual set of antennas, driving through to look at the data flow and the connectivity all the way through to the Science Processing Center, and then, as Phil noted, to the SKA SRCs, basically, that are distributed more globally and handling sort of that curation and distribution to the communities. And then similarly on the mid side, there again seeing this sort of spiral pattern. You'll notice there are 2 different colored dots there, of course, again noting that the Meerkat antennas are really concentrated toward the core of the array, but that it's the overall combination that's being used there. We're exploiting the existing facilities that are on the ground that are supporting the Meerkat Observatory, and then again out connecting to the Science Processing Centers, and then off hopefully to our community of users. And then this is just showing snapshots of the existing status that with regard to the prototyping qualification and the state of the designs. This is a verification system that was deployed in the Murchison, right around where the observatory will be. And this is showing kind of the SKA 4, this sort of 4th iteration of this prototype antenna that's been tested and has performed really robustly in that environment. And then on the right-hand side is the second prototype. This is the prototype provided through a Max Planck support with Soreo, working again with all the partners, SETC and SAM in Italy, to produce one in that environment, actually on an SKA foundation, and that's still being tested and reviewed for all of its properties. But a lot of work has gone on to characterize and capture, in this pre-construction phase, the performance of these prototypes to help us inform moving ahead into construction. What is the manufacturing? Are there any lessons, final tweaks in the design that we need, knowing that we have to roll these out on a fairly significant scale? And so the next is, I'll just kind of throw in some of these. That's not just sort of the big structures and the disk structures, the antennas and the stations, but a lot of the components, a lot of the pieces of the system. If I had a block diagram, a lot of those have been prototyped in detail to make sure that everything is really going to perform as we need it. And so the different receiver systems for mid-band 1 and the cryostat for the 345 and then band 2, and these have been tested and I think are really in a good state to advance. And then racks of electronics that have been deployed in support of the stations, and then correlator board representations, prototypes for the low and mid as well. And then of course we've got, in addition to all of the hardware, there's also an immense amount of software that's involved in the observatory, very much a software instrument as a way to look at it, integrated in every aspect. And so one of the things that we're doing in the project that I think India in particular has helped us pioneer, been on the vanguard of that approach, is the scaled agile framework suite of processes that we're using to develop our software. And this diagram is just kind of showing how that's really meant to work. Basically, it's predicated on putting things together early, testing constantly, and going through the process iteratively, and then slowly adding on the functionality, but not having that maybe more traditional waterfall approach where you establish a set of requirements at the very beginning, and you hope you get back what you needed many years later. And instead, it's really coupling the developers with the owners, those that are invested in the results, all the way throughout the development process, to really make sure that you understand what it is that you need all the way throughout, and maximizing what is the highest priority at every step of the way, and kind of doing that on a rapid loop. And so, and then this is just kind of showing a bit more about an architectural view of one of the minimum viable products, these MVPs. And then I've got some GUIs here in operation. I can see that I was paralyzed by the immense amount of things I could do. There are ongoing demos through every PI cycle, and they're going on right now with the OMC and SDHP. But just showing a few of those, I picked some older ones. And then this is another one of the GUIs and one of the racks. This one's actually been deployed at Meerkat, but showing some of the test data from the pulsar timing, showing one of the pulsars and the actual Shapiro delay that was detected. And so these are working systems now that we think that we can model on for the full production and into the construction phase. Now, Phil covered this as well. The amount of data, I wouldn't call it an issue. I would say it's a challenge, but it's ultimately the observatory is so driven by a large body of interconnected software systems. Sorry, thanks. And so many of those systems are very functionally recognizable to you from other observatories. The science management side, proposal handling, observation design, scheduling, execution, and tracking, the monitor control, the real-time coordination of hardware and software systems that collect the operational support data, and then the acquisition of the science data processing, the calibration, imaging, time domain analysis as appropriate, and then entrained in all of that, of course, is the business or enterprise systems that support the functioning of maybe those non-science aspects. And so as you saw both from Phil's diagram and mine, if you look at the numbers, the data processing becomes exciting when you're on the scale of an observatory like the SKA. The data rates coming off the antenna systems with a little bit of processing on site, in particular for the low array, but they're still fairly extreme. And then the transport to the science processing centers where the standard data reduction has to take place. And I have slightly, I think, different numbers from Phil, because mine is really based on a weighting of the expected science objectives that will evolve. I think Phil was representing what those maximum data rates could look like over time. But these are things that are going to evolve. We need an architecture that at some level is modular and supports that kind of emergence of areas to be able to adapt to that. And I think that's what we have going forward. So now is the exciting part. So Phil did talk about the schedule a little bit, and I can go back to maybe some of the questions that were had if there's still more around that. You can see on the left-hand side this sort of course breakdown of how incrementally the observatory is laid out. Basically, the program for construction and handover is about 8 years, and that includes the time to build these incremental array assemblies. That is, these subsets of the interferometer. We build them fast, we build them early as we go throughout. And alongside, on the right-hand side, is a bit of a rollout plan. You can see these array assemblies, and on the low side, the number of stations involved. And on the top is sort of a subset of the observing modes, if you will, that we're looking at to kind of incrementally get to a point where we can test these, demonstrate them up to the full science requirements that are needed, and do that over a period of time, kind of looking at the system, challenging it, making sure that we're on the right trajectory, and then hopefully ultimately delivering that. The question about when do we have data that'll come out, I think Phil did answer that, but the idea is that there is engagement with the community throughout this process. And as we get to a scale where the facilities are kind of on par with existing facilities, then we can use public releases of data to help us guide through that final execution phase and the subsequent delivery of the observatory. And we can use that to kind of channel us to what the final, through that final science verification. And so this is kind of showing the ambition that we have in terms of the subset of observing modes. There will be many more of these. They become richer over time through the operations work that's going on. But looking at this is what we think we can deliver and test kind of continuously, repeatedly, getting to the point where we feel good about that delivery. And then Phil did mention, of course, that that 8 year does include some contingency. Things don't always go according to schedule. We know that there are known uncertainties built into our planning right now, and we have to manage that over time. And that gives us some of that ability to manage so that we're aligned with the expectations of the community. We're not telling them, oh, we're going to be late, we're going to be late again, we're going to be late again. We're trying to build within a predictable framework. If we come in a little earlier, that's great. But right now, I would argue that that contingency that's in there is actually needed to provide us the ability to manage the many different things that are going to go in the execution of the project that are going to challenge that in the timelines, conflicts between contractors, or just it takes longer to do certain things as we go. And there are uncertainties in that we've planned in. And so this is the low representation, and here's the mid representation, kind of similarly aligned. You can see the different number of dishes in this case, and so a small number 4, kind of that subset, that minimal system, if you will, testing out the basics of the phase closure, amplitude closure. Is the system integrity all there? And then kind of rolling it through where you've got partial implementations to the full implementations, and even indicating there are some areas where we can strive for it, but maybe we won't attain it at an earlier stage. But it gives us an idea of what we can try to plan to and what we might be able to produce in terms of those early bits. All right, so go here. I felt like I needed to put on something. You can't probably see this, but you'll have it in the slide representation. but it's just kind of trying to capture in a very summarized way the set of technical aspects that we've designed together that the SKA-1 will be able to deliver to our community. The red bits are just highlighting again those designed in but not planned in parts of the SKA-1 for the mid. That isn't the case for the low observatory. Okay, and then here, this is just a roadmap-like schedule that's kind of showing where we are right now in our planning. As Phil indicated, our intention is to begin construction in the middle of this year. And begin construction means that we have the permission to do so, we have some funding to begin that process, and we can begin to procure, we can begin to award contracts for the many different things that we have. And because this really is a system, our contracting is fairly complex up front. And so there's been a long preparation stage of us getting together all those contract groups so that we can be ready for that first burst of both advertisements, looking at what areas are going to be competed for versus which ones we think we might sole source given historical investments, and being able to drive forward. But it shows you the history of what we've gone through to get here, and then basically where we are right now, where we've had our first council meeting, and now we're going through and refining our plans up to the point of hopefully getting that approval potentially in June to start in the July timeframe. And so maybe Phil also showed this, but just kind of noting again that the investment overall is substantial. The construction side of it is above €1 billion to get through that, and an overall investment over this 10 years. And I think what's been a strength of the SKA, again, learning from other observatories, is you don't isolate the construction and the operations. They have to be very tightly coupled in the planning stages so that you have a coherent observatory. You build what you can operate. And I think that's what we have here. And the view of this is that this is a coherent whole that we have going forward. I would note there is an area, so one of the questions that came up is, the future development. There is something that we have tried to build into the SKA planning, which is the fact that the lifetime is 50 years. It's got to evolve over that period of time. And so there is a development program that looks at a technical roadmap, a scientific roadmap, these emerging frontiers and enabling technologies as they come available. How might they be able to support enhancing the capabilities over that lifetime of the observatory? And there's an investment made by the members to making sure that we can do that going forward. And the last, again, I would say Phil showed this, but I just kind of wanted to emphasize the fact that this is a large research infrastructure. It's really hard to do. And so how do you do this? Well, we can look at how they've done others like ALMA and other examples like that. But generally, they take a significant investment, and it requires the collaboration of countries and institutions to come together to pool not just their funding, but their expertise, their knowledge, and their all of what they've done before, pulling all of that together to build a new facility. And the SKA is very much built on that model. So it does have currently 14 member countries sort of in the organization, and then 2 more that are looking to jump in and joining, and that makes up really what we think we need. And I would say that India has been critical throughout this process. It permeates the areas both in the design stage and now in our planned construction for the delivery of the observatory. And that the expertise that's been developed within India is needed for the SKA and is a core pillar that supports the work that we're hoping to do in the coming years. So the summary slide is just that we're basically done the pre-construction phase. It's time to get to work, which is maybe hard to say given how hard it's been to get to this point. But we are anticipating a start of construction in 2021. I want to kind of just put on the bottom a little bit. It's a big investment. It's a long time. It's a lot of funding from a lot of different governments. But just maybe in a very visceral way, looking at what the promise of the SKA is, and you can see these on the there are 2 pairs of images. On the right-hand side of each pair is sort of a representation of what a sort of the state-of-the-art observatory can do right now, looking at a particular image in the case of here of the Crab Nebula, and then what the promise of the SKA could actually deliver, kind of almost amazing fidelity, imaging fidelity and capture. And it's not just the taxonomy or the beauty of the images, that's nice, but that's the detail that's actually needed to make the breakthroughs in understanding the physical processes. And that's where we're really driving on with each of these. And so that's what the SKA-1 is. And I think I'd love to take some questions.
Thank you, Joe, for an excellent talk. We will now open, we're now open for taking questions. So with those on the Zoom call, you may just raise your hand so that we can ask them in order. If you prefer, you can also post them into the chat. And for those of you who have joined us on YouTube, please go ahead and comment as a YouTube comment, and we'll pick up the questions from there.
Given there was a latency in the questioning, I won't presume that I was crystal clear.
Yes, yeah. We once the questions start, let me while we wait for other questions, let me kick off with a question. The cost table that you just showed, are these 2020 euros or in some other numbers?
Yeah, that's a very enlightened question. Yeah, so anytime someone shows you currency, you better ask the units of that. And you're exactly right. Those are 2020 euros. And so the program does have built into it a regularized escalation and adjustments. There has to be some kind of correction. So there's a windowing process. So we'll do this sort of annually as we go forward with maybe a part projection, and then we'll correct that projection in the subsequent year. So overall, the escalation should be tracking what we're really experiencing on the ground as we go forward in the observatory. I've got one question in the chat I could begin to answer, if that's okay, Yogesh?
Yes, please go ahead.
Yeah, are the prototyping activities concluded? That's a bit of a tricky question. It's sort of yes and no. I think we've gotten to a state across a large part of the design where we're quite comfortable, I would say, advancing toward the procurement stage. There are other areas, I think there are design refinements, design maturity for production that we'll want to build in. And those are activities that we can take up and had planned sort of the design build type contracts in some areas to do some of that refinement as needed. And we've got some additional work going on from some of our partners to do that actually early, even before we start a construction, which is fantastic because that really reduces risk. We do have two outstanding areas that we're still working on, and one is in the with prototypes, you learn things, and we did find some non-compliances in our final deployed prototypes in the low array, in particular in the areas of the power and signal distribution. And it's a very solvable problem, but we're deciding on how we want to solve it and then finalizing that design. So I would say that prototyping effort is still going on. That will actually carry on through the summer of this year, where we'll deploy a revised prototype and make sure that everything looks good before we kick into the production. And that's still within the schedule, but the prototyping effort is there is a part of that that's going on in tandem. And the other aspect is maybe more significant, and that's in the area of the mid-dish structure. And I mentioned that we've had two prototypes, one deployed in China, one in South Africa. And of course, again, we did learn things there. And one of the earlier questions was on the RFI situation. One of the big worries we have is self-generated RFI, that is from the electronic systems within the SKA itself interfering with our observatory. And so that's been a tricky problem to disentangle. We had the benefit of having a working observatory there with Meerkat, and so there is spectrum management happening there that helped us understand the issues, and those have been resolved essentially, and had to go through a subsequent refinement stage and redeployment and qualification. And so I think we're getting to those stages. There's a long lead time on some of those aspects in the mid-dish systems, but right now we're still looking to kind of finalize the design over this year and have them, on schedule for when we need to let the contract to go forward for the procurement. But so there is still some ongoing prototyping activity. Is a shorter answer.
Yeah, Dipankar, did you want to follow up on that?
Let me unmute myself then. Yeah. No, I was wondering whether just when you say that we start construction, all systems are fully designed and a go, or is there some refinement still happening? Because right in the start of the construction, all subsystems are probably not being constructed simultaneously. So is there some phasing there? That's what I was wondering.
Yeah, let me take that. So the reality is that we actually need to go pretty broadly across the spectrum of the systems, what had been traditionally the consortia, pretty soon out of the gates, because our maybe laser-like focus is on that earliest representation of the array, that array assembly 0.5, which is just a few stations and a few dishes in both the low and mid facilities. So we really do need to go forward very quickly. With that said, where we were at the end of this long design process that I described is we have a reference design at that point. And so we are, and so you can argue language at some level here. Are you a build to print observatory? That is what we've got at the end of that, you just make some of that. Or are you a build to specification? And I would argue that we're largely a build to specification, that this process has revealed the specifications that we need. And we have a reference design that illustrates qualified designs that can meet those specifications. However, we've done these in some cases in small labs and even academic institutions. Now we need to produce, and take the case of antennas, 131,000 of them. And so there's a design aspect of the production runs that we need to make, that scalability. And so I would say that I use the phrase design build, that in some of these cases, and even infrastructure as an example, infrastructure we well understand, but do we have it down to every bolt and dollop of concrete? No. That's a process that we'll go through. So take maybe infrastructure as the example. We'll award an initial contract right out of the gate that is providing professional services that's supporting us in areas that the observatory is not skilled at in terms of those attributes. And basically, they'll help us in the contracting of the downstream. So it's all the aspects of the buildings and the utilities and things like that going forward. But they'll also, in the process of doing that, they will do a final design, kind of carrying that all the way through down to the lowest detail that we'll do a review of before we go forward and do it. And that period takes about 6 months. And so even though we start construction in July, we'll have maybe camps on the ground beginning at the end of this year, and then real things happening sort of in the beginning, first quarter of 2022 is the reality of the situation because of that design finalization going forward. And that's similar in other areas as well.
Yeah, sure. Thank you.
I can see a few questions coming in on the YouTube channel. We can take one here, which is, will the SK also work in collaboration with the VLBI? This is a question from Pranav Limay.
Short answer there is yes. That's been something that has been incorporated into the design considerations all the way throughout, and we've kept that coupling. And so that is in an observing mode. That is an aspect of our delivery and is actually a part of the initial delivery for the start of operations.
Okay. There's one more question on from YouTube. Are there features of the GMRT that SKA will take inspiration from?
I think broadly, yes, that's the case. I think all of these precursors and predecessors illustrate a lot of the aspects that we have to realize in the construction of the SKA, from how do you go about building these complex integrated systems and how do you test them? And so the lessons learned, I think, are often in this incremental testing as you go, putting the systems together, demonstrating them. Now the GMRT, the scale of things is different, but the lessons still apply. And then other areas, I would argue, are in terms of just the operations. How do you operate these facilities and maintain them over an extended period of time? How do you learn to enhance their facilities to maintain relevance to the evolving scientific frontiers? All of those are things that we have to continually reassess and reevaluate in our process improvement, borrowing from facilities like the GMRT. So that's the very broad way of looking at it. I'm sure there are more specific examples I could give as well.
I mean, if I may add a specific example, we use the Tango framework to design and build a new monitoring and control system for the GMRT. And this is effectively going to be a prototype for the design of the full SKA monitoring and control system. So that's one example of something specific that was first tried out and demonstrated to work at the GMRT, and which we hope will also work for the SKA.
And maybe just to note, that's not a small example. That underlies the fundamental architecture of the control system for the SKA.
Are there any further questions from the Zoom participants? Okay, so I think we can move on to the third speaker today, which will be Yashwant Gupta, who's going to tell us about the SKA from the Indian perspective and the work that we've been doing over the last many years. Over to you, Yashwant.
Okay, thanks, Yogesh. I'm going to share my screen, and then you have to just tell me whether you can see the presentation. Can you see that?
I can see that, and I can see it in full screen mode as well. Yeah, so I think we are good to start.
Okay, and is it sort of fitting in the screen? Because on my screen it's...
It is going out a little bit.
Yeah.
Part is out.
Let me just adjust that. Yeah, is that correct now?
Yes, this is better. The presentation mode that you just.
Okay, so good afternoon to all, and good morning to Phil and Joe. So usually when I give a talk of this kind in a SKA workshop in India, I need to start with a long preamble about what the SKA is and what are its specs and what's been done. But today, thanks to the excellent coverage by Phil and Joe, I don't need to tell you all about what the SKA is and what are the plans for building it. And I will therefore plunge straight into the main focus of my talk today, which is about what is it that we have been doing in India in terms of our participation in the various aspects of the SKA. And so I'll just start with a bit of a background because again, there is a diverse audience here. I know there are lots of younger members, students who are connected. And so I will just start with just a bit of a background about what has been the history in India in radio astronomy. And the fact of the matter is that we do have a fairly strong tradition going back from the 1960s when radio astronomy started in India. And there are many institutions where there is active pursuit of radio astronomy, with NCRA and RRI being perhaps the two of the most well-known institutions in India doing radio astronomy over the years. But there are a few others like the Indian Institute of Astrophysics, the Physical Research Lab, and today more and more of the new institutions, the ICERs and the IITs, and the other universities getting into radio astronomy. So it's growing significantly in India, and that is one of the reasons that gives us some good confidence to be able to be a major partner in the SKA. We also have some world-class facilities like the GMRT, which has already been talked about, which has been active from 2002 onwards. It attracts users from all over the world for various kinds of science. And what makes it even more useful is that we recently completed a major upgrade of the facility, which was released a bit over a year ago. And that has further enhanced the capacity. And it enjoys the status of SK Pathfinder facility, which was again talked about. And that means it has both relevance for science and technology developments. And just an example of where the upgraded GMRT stands in terms of sensitivity vis-a-vis the other facilities. And you can see that this why one could be doing interesting science with the upgraded GMRT, which would be a stepping stone towards being able to do the next generation of even better science with the SKA low in terms of the sensitivity capabilities. And in terms of the technology developments, you already heard this example being talked about, that there are things that you can do in terms of technology development, which can be useful for the learnings for the SKA. And Joe mentioned about the general process of learning from the existing large facilities. And Yogesh gave this specific example about the Tango-based monitor control system that we've developed and are now using for the upgraded GMRT, which is really for us a very useful demonstrator and stepping stone for building the bigger system for the SKA. And even other colleagues, like particularly the Raman Research Institute, have been actively involved in international projects like the MWA, which is a SKA precursor facility located at the SKA site in Western Australia. And so overall, we have a strong and vibrant radio astronomy community covering many research organizations and universities using both national and international facilities. And that makes us well placed to be participating in a large international project like the SKA. And if we just go back and trace what has been the history of Indian participation, we've been part of the project from the very early days. Even some of the early ideas that were tossed about building next generation large telescopes had contributions from the Indian Radio Astronomy Group. But more concretely, during what was called the preparatory SKA phase, 2010 to 2011, we actually led the concept design work for an SKA monitor control system, which was accepted by the SKA, which then led to what was called the telescope manager during the design phase, which was an activity that we led. I'll talk more about that in a moment. And in 2012, we joined the SKA organization as observer status, and that was NCRA. And in October 2015, this membership was then transferred to full membership with the Department of Atomic Energy representing the Government of India. And Phil will remember this from one of his numerous trips to India, the time when India signed the membership documents with the Secretary of the DAE doing the honors from the Indian side. And over the years, India has then contributed significantly to the activities, both in terms of science and technology, and I'll talk about that more in a minute. It is, for those who may not be aware, all the activities related to SKA happening in India are coordinated by the SKA India Consortium, and all of that funding up to now has been coming from the Department of Atomic Energy, though as we move forward to the construction phase, we expect this funding contributions to come also from the Department of Science and Technology. And so a moment to just look at what the SK India Consortium is. It was basically set up in 2005 when we joined as a full member in order to grow the activities in a coordinated and organized fashion. And so the SK India Consortium coordinates all SK related activities in the country. Today, there are over 20 institutions that are members. All the main astronomy research organizations are there. And several of the Indian Institutes of Technologies, the ICERs, and many universities and colleges are members. And you can see there's a fairly good spread over the entire country in terms of where the membership comes from. And each member institution of the SKIC has one representative in the SKA Council, which is the main discussion and decision-making body of the consortium. We also allow associate membership from individuals. So if you want to be a freelance member not associated with any organization, you can join as an associate member and contribute to the activities. The consortium has two main subcommittees, science and technical subcommittees. The science subcommittee coordinates the SKA India science working groups and the related activities, pretty much all activities related to science. And the technical subcommittee coordinates pretty much all the activities related to the participation of India in the SKA work packages, which so far was the design phase. And I'll just talk a little bit about the science activities. And so it was around December 2016 that just about 2 years since the consortium was set up, that we were able to organize the scientific community to come out with the first science case for SKA by the Indian community. And it was published, as you can see here, in the Journal of Astronomy and Astrophysics. And since then, there has been a continuous refinement and improvement of that science case with a major revision that happened in June 2018. And more recently, as part of our preparation for putting in the detailed proposal for funding to the government for participation in this 10-year construction period, there is now a even further refined and mature science case, which you can find on this particular link on the SK India website. And today there are more than 100 faculty postdoc students from these 20 odd institutions that I talked about were involved in this exercise. And we expect this to more than double by the time the SKA is ready for early science. And that's one of the main goals, is to be able to have the science community up and ready at a level where they can really make good use of the SKA. And so there's been active participation from the members of the Indian science working groups in the SKA science working groups, including some of them being co-chair in some of the groups. And the range of the science covers theoretical studies, simulations, use of SK Pathfinder facilities, in particular, synergy with the UGMRT is what we try to emphasize in the working of the science group, but it's not confined to that. Many of the science members have been using other facilities for furthering the work on the science. And for those who are more interested in more details, I'd encourage you to visit the SK India Science webpage, as seen here. And you will find a full 80-page document about the SK India science case, which we recently prepared and is available for our ministries to look at as for the kind of science that we have in mind. And this is something that I do want to just point out in passing, that in it was actually this meeting, which I would say was one of the trigger points for really developing the science activities in India. And so we hosted the annual SKA science meeting As you can see, it was very well attended. And this was also about the time when we produced that first science case document from the Indian astronomy community. And so this attracted a lot of attention, a lot of the younger generation, people who were not aware of the SKA and the science that could be done. And that has caused a significant, given a significant impetus to the science activities in the country. So I'll move from there and talk a bit about the technical activities that India has been involved in. And you heard about the design phase, which went on from 2014 or so till 2019, actually early 2020, when the final design was accepted. And we were involved in 3 of the design work packages: the telescope manager, where we were the lead country, and central signal processing, and the signal and data transport at the smaller levels of involvement. And we, working with partners from software research groups and industry, we took the lead role in the design of the telescope manager. And the telescope manager has already been sort of hinted at, is one of the critical and all-encompassing system of the observatory. It is like the brain and the nerve center. It provides the end-to-end monitor control for the entire observatory. And there's complex software needed for complete life cycle management, all the way from proposal submission by the users to the final data delivered to the user and verified. And so this is, in a nutshell, trying to capture how Telescope Manager is connected to every aspect of the observatory. And all the way from the operator and scientist, as well as engineers, to all aspects of the flow of the signals through the observatory. And this design work was done 2014 to 2018, and we led a consortium. And this was interesting because, as you would have gathered by now from listening to the earlier talks, that the SKA is a major exercise in collaborative work. And that was a very interesting learning experience for us to lead a consortium with partners from different countries, different time zones, different cultures, and also having some amount of participation from industry in the different countries, with a significant amount of industry participation from India in the design phase work. And so this all has been a very great learning experience. It has given significant insight to our industry partners as to how some of this work is to be done and what does it involve. And we already have a very good pool of human resources trained both within the institutions and in industry to move this forward during the construction phase. And this, as was already talked about, we tried wherever possible to do work which can be synergized with our own activities, so that we can both benefit from that activity in improving our facilities, as well as provide learning and experience, which would help in the more complex system that the SKA will be compared to, say, a facility like the GMRT. And this is an example which, again, already has been talked about plenty, but I just wanted to show this to emphasize that we actually did this. And there have been very interesting learnings about what can you do in Tango, what may be possible limitations, which we've ironed out and got a working system at the GMRT. But I'm sure that the people who've done this will be able to provide valuable insight as we go into the construction phase for the SKA. And this was one of the first design consortia to finish and clear the critical design review in mid-2018. And I'll tell you later what we've been doing since then. And this is something, again, it attracted significant attention, both within SKO, as we were the first people past the post, and as well as in India, about the contribution that was made to the SKA. We also participated to a smaller extent in central signal processing and signal and data transport design packages, and we are hoping some aspects of that may be picked up or complementary aspects as we move towards the construction phase. And the point that is worth noting is that in that process, we have built up a strong and viable industry interaction model. It also goes back to the building of the digital systems for the Murchison Wide Field Array done by the Raman Research Institute, where again, there was the significant amount of the construction that was outsourced to industry. And that is again something that we are hoping to leverage for our participation in the SKA law. And just a bit about this, this bridging or prototyping phase that was also talked about earlier. That so since completing the telescope manager design, we've done a significant amount of early prototyping work, which has really helped to clear many of the open questions, including how you would actually do the interface with the other elements of the SKA, which is one of the most critical aspects of making it work smoothly. And as I said, there are people who've from India who've gained valuable experience and beginning to play some key roles. And we have also been contributing to the bridging activities in the pulsar search processor, in the science data processor, which is also one of our areas of planned contribution in the construction phase. And most importantly, we joined the SKA Low Station Digital System Group for participating in the prototyping activities, and are now beginning to contribute in this area of work, getting ready to have the first set of the hardware of the prototype SKA Low digital signal processing boards available in our labs in Pune and Bangalore, and be able to start working on them in terms of testing them, helping to work on the firmware for improving that, and then thereby gearing up to be able to produce those systems in India and supply them to the SKA during construction phase. And as was briefly alluded, we've have Indian teams participate in the SKA Data Challenge. You'll hear a bit more about the details of what the Indian teams have been doing. I mean, there were Indian teams in the Data Challenge 1 also, but in Data Challenge 2, we've managed to have a much larger participation, which I think again reflects our ability to have grown the interest in the community in India to be able to involve in these kind of activities. So from there, I'll move on to looking up towards the construction phase. And again, this I will not talk in much detail today, because this is really the subject of a lot of the discussion tomorrow. There will be detailed presentations on each of these different items, as well as discussion on the industry interaction for these different activities. But I'll just give the nutshell of the thing here, which is that we have been, as part of the provisional allocation of the work packages, we have been identified as the lead country for building what is no longer called Telescope Manager, because it's an enhanced version. It's called the Observatory Monitor Control System, the OMC, which is the original Telescope Manager, plus all the local monitor control systems of all the elements now added into it. And so this is, we are expected to contribute about 50% of the work in this work package, and working in partnership with 5 other member countries who will be contributing the remaining. And this is something that we feel that given the experience and the ability that we've demonstrated over the last 6 years or so, that we are very well primed to take up this work and deliver it. In addition, we are now included in the SKA Low construction team, and where a lot of this work will be led by colleagues from Raman Research Institute and other SKIC members. And again, there will be significant contribution of Indian industry in building and delivering these digital signal processing boards for the station level processing of SKA Low. And we have a role in the SKA mid construction effort, where we are partners with the lead country, Sweden, to build the band 1 feed in the country, which again will be finally mass produced by partners from industry, where again we've identified potential partners who would be capable of doing this. And we are also included in the science data, which is actually now called SDHP package, for as a member of the pulsar search processing team. And overall, our aim is to be able to have a contribution which is somewhere around 6% or so of the total construction cost of the SKA. And we do hope that there would be additional scope for Indian industry to bid for some of the open contracts from the SKO, which are over and above what is the what is India's committed contribution to the project. Further to this, there are plans for activities in India so that we can support this participation, namely a regional data center, which will house some fraction of the SKA data and specific post-processing pipelines, which may be of relevance to the Indian science community, as well as all right, so I think I missed one point, which may come later, about in-country human resource development. But there is a aspect which is basically tied up with the science case and the science community advancing, which again was referred to earlier by Yogesh, that there's a significant component for human resource development within the country, both in terms of science capabilities as well as technology capabilities, which would both help us in our participation in the SKA as well as in general in radio astronomy and astronomy in a broader context. And so that brings me to what we have now is that, as you heard already, that the plan for the SKA is complete construction of SKA-1 and start of the regular science operations by 2029 or so. And what we have now put together and submitted to the government is a detailed Indian proposal, which has a breakup which is roughly like this, that as you heard earlier, that the cost for the SKA consists of different components. There is a capital cost of construction, which is for building all the hardware and software that was described by Phil and Joe. And then there are the commissioning and operation costs, which will be realized by annual contributions. And as per the arrangement that the SKA has adopted, a country can contribute up to 70% of their contribution to the capital cost of construction as via in-kind contributions, which is the preferred mode that the Government of India prefers when supporting participation in such large projects. And so these are items that would be built in India and supplied to the SKA. And these are the ones that I already talked about, where we will be the tier 1 lead country for the delivery of the observatory management and control system. And we are the second largest contribution in the SKA low digital signal processing system behind the lead country, which is Italy. And as I mentioned, the band 1 system for SK mid and contribution to the PSS. And the remaining 30% of that contribution to the capital cost of construction is via cash contributions to the central procurement process that the SKA will run. And in addition, we will be providing our share to the commissioning and operations cost, which will be via annual contributions. And in addition to this, the proposal, as I mentioned earlier, has a significant component for in-country expenses, and that is to build the data center in India, of which you'll hear the details tomorrow, so I won't talk too much in detail. A prototype version we will build in the first few years, which will be synergized with storing the larger volumes of data from the upgraded GMRT, as well as possibly from other radio astronomy facilities, and the learnings from that to be utilized towards the development of the full data center in time for the 2028-29 timeframe. And as I mentioned earlier, again, there's a significant component for human resource development for the science community, as well as a significant component for in-country R&D, which is not counted as the direct contribution to the SKA project. So these are items which are outside of India's direct contribution to the SKA project and have been put in, keeping in mind the need to be able to develop the community and the facilities in the country. And the current status of this is that the detailed proposal for this is currently under review by the DAE and the DST, which are expected to be the two major funding agencies for our participation in the SKA. And we are awaiting this final approval for both the funding for this duration, as well as the approval for India to join the SKA treaty. As you heard from Phil, we have not yet signed and ratified the SKA treaty, and currently we are now observers in the new SKA Observatory Council, which had its first meeting on the 4th of February. And we are hoping to be able to change that by the time the project actually kicks off into construction phase, assuming that we have the final approval by that time. And so that's where we stand. It's an interesting and exciting juncture where we've done significant work, and there is very good preparedness for going on to the next phase. And if there is people who still want to understand, I have this here. I'm not going to read all of this, but the benefits for being in a large project like the SKA span a variety or a range of aspects. And I think it is something that we ought to keep in mind as we think and plan for the SKA. So with that, I'll just put up the summary and stop here and take questions.
Thank you, Yashwant. We're now open for questions on Yashwant's presentation. So again, those of you on Zoom, you can sit directly or on the chat. On those of you on YouTube, just type it in as a comment and we'll pick it up from there.
Okay, that's good. It looks like there's somebody. So I can read that question in the chat box.
Yeah.
So it says that from science and technology perspective, SKA will augment GMRT or replace GMRT post 2030. That's a question that I think all countries which have large facilities have asked, and I think what you will find is that though the SKA will be much larger than any existing facility, it is not going to be able to do everything that is possible in terms of the different areas of science. And there will certainly be niche areas of science, as well as lots of follow-up activities of various kinds, which some of the more sensitive facilities around the world would be able to take up, complementary activities. So there was a question asked in the previous talk about, for example, VLBI capability with the SKA. To do VLBI with SKA, you will need facilities with comparable sensitivity located in other locations on the earth to do the VLBI with. And so there will be scope for many of these kind of activities for a facility like GMRT. So it won't replace, the SKA will not replace. It may well help from the learnings from the SKA. One can improve existing facilities. And of course, there are plans that we have for further enhancing the GMRT, which would be dovetailed with the wider plans for Indian participation in the SKA. So as I mentioned earlier, we recently finished an upgrade, and a time frame of 5 to 8 years is when you start asking, is this scope for further improving or expanding a facility? And that question is being asked about the upgraded GMRT. And so there are those are the kind of things where the work done for the SKA will be synergistic with some of these growth paths for our own facilities and in different member countries.
Nobody's raised their hand, looks like. I have one question on the YouTube channel, which is from Shayan Basu. He says, I'm a researcher at the South African Radio Astronomy Observatory, Sarau, which is, of course, heavily involved in the SKA. I'm interested to know about NCRA's involvement in the project. Sorry, I joined late. So I don't know whether you want to comment on that.
Okay, it depends on how late he joined. I mean, that's like pretty much a rewind of the talk. But I just, I mean, I will say it in maybe 2 sentences that the takeaway message, if you see even from the summary screen that I have still up there, is that India has significant involvement in the SKA. A lot of that Indian involvement is led by NCRA, though now we are having more and more participation from many of the other SK India consortium members. So that should give you a sense for where NCRA stands vis-a-vis involvement in the SKA.
Yeah. So this talk is being recorded. We'll put up the individual talks on YouTube. But even right away, once this stream ends, you should be able to rewind and watch Yashwant's talk again on YouTube. Those of you who missed it. Are there any other questions or comments?
Yes, Dr. Yogesh, can I ask a question?
Yeah. Go ahead.
Yeah. So we did came across mention of regional data centers during Phil's talk. So is there a site identified in India for setting up the regional data center? Can we assume it is in Pune or?
Yes, you can assume that there's a very high probability that it will be in Pune and likely to be in NCRA. And maybe there may be some more detailed discussions about this in tomorrow's session.
We have a session dedicated to the SK regional centers tomorrow afternoon.
Sure. Thank you.
So there is one YouTube question, Yogesh.
If you can see it, can you read it out?
Yeah. I would like to know, this is from Uday Shankar, I would like to know when the tenders will be floated for the outsourcing activities.
So I presume that that's a more specific question about tenders in India rather than a more general one to somebody like Joe about tenders in the
Yes, I assume the
SKA project, right? Yeah. So, so this depends a little bit on the timelines of the approval process and also the requirement vis-a-vis the main the overall timeline of the SKA project itself. So you heard about the planned timelines from Joe as to when the kickoff is supposed to happen and when we're supposed to be in construction and the various milestones in terms of the array releases. And our aim would be to synchronize with them, but it's a little bit dependent on when we get the clearance from the final approval from the government for the go ahead, and so what. But I can talk a little bit about the steps that will be involved in most of these industry participations, and which is something probably will come up for more detailed discussion tomorrow, which is we would have some kind of initial pre-qualification process for the industry partners for any one of those kind of the work packages, either the software or the hardware items that I talked about, followed by an actual tendering amongst the pre-qualified industry partners. And the earliest I can see that happening is the is at least a few months after the approval comes from the government. Though we are talking about the possibility of running the pre-qualification process even during while we are still under the bridging phase funding support. But those are things that are still under discussion because the timeline for this approval is still evolving, in the sense that one doesn't quite know when it will happen, and so it's I mean, I think that's the best probably one can say at this point about the timeline for actually having the tenders out for the different activities that India will be, the work packages India will be providing to the SKA.
Are there any other questions?
There is one more YouTube question. Question is from Kiran Mehta. This is regarding the FPGA programming skills. Are they getting used in the SKA? In what different ways can individual developer can engage in such tasks?
Okay, maybe Prabhu, you're the one who's best placed to answer that question. But the thing is that definitely the answer is whether FPGA programming skills will be required for the SKA. That's a very strong yes. I think you would have got the sense from Joe's talk about the large volumes of data that's being handled and processed, and a lot of that is real-time processing. And today one of the best platforms for doing heavy duty real-time data processing is still around the FPGAs, and that is what is a lot of the digital hardware is likely to use FPGAs. So there may be some fraction or some part of it which may have GPU based computing, and so definitely there's going to be very significant requirement for expertise in FPGA understanding, as well as coding, firmware, and so on. I briefly alluded to it when we talked about the prototype digital boards for the SKA low that we are now beginning to work on at the labs in GMRT and RRI. And the team members from there who are already experienced in doing this are going to be very heavily involved in that work. Now, when it comes to asking, I don't know if your question is from individual members who can contribute or industries who can contribute. I think there is scope for both. There's only the mechanism for engagement would have to be then worked out, and we'd be happy to have the discussion with you later on if you have particular interests as an individual or as a company.
Any further questions from the Zoom meeting group? I'm just checking if there are any questions on the YouTube. Okay, there is one question about tomorrow's session, which has already been answered. There's a question: is there any telecommunication dish in India being upgraded for science as done in the African LBI network project?
Yeah, I can answer that very quickly. The answer is yes. We are actually currently in discussion for doing that for a set of telecommunication antennas which are located not very far from GMRT, which was earlier the primary telecommunication link for all the overseas communications from India before the era of optical fibers. But we are some ways from being able to actually make that into a working system. But there are active plans which are afoot, which are coupled with a larger VLBI network in the country, which would be for dual purpose, both astronomy and geodesy, that is being planned.
Okay, I think we have. If there are no further questions, I will. I'll thank all the three speakers of this afternoon's session for their excellent presentations and for answering all our questions so patiently. We're not done yet. We are going to have a summary and wrap-up session. This session will be coordinated by Dipankar Bhattacharya. And so I request Dipankar to take charge. And we can continue with the questions, clarifications on any of the three talks that you want. And I'll let Dipankar control the proceedings from here on. Thank you.
Thank you, Yogesh, and welcome everyone to this discussion session. So in this discussion session, it's meant to be an open discussion. So if you have any questions which have been, which are related to the talks which have preceded this and which have not been answered yet, you are free to raise them. And you can raise questions where the answer is not necessarily meant to be given by the previous speakers, but other participants who have joined in here as well. So we have seen various aspects. We have covered various aspects of the SKA in the previous talks, which is including the kind of science it will be doing, the nature of the telescope that it's going to be, the technical design, the status, how India is going to participate, and what kind of facilities we can expect in India in relation to it. As well as there were discussions about how India will go about doing this participation and the human resource development. So now you may also have questions regarding how you can participate, and you can raise those questions here as well. And remember that tomorrow there is a full session, and idea today was to, through these discussions, prepare the ground so that you are fully engaged in the sessions tomorrow. So any questions? If anyone has anything to comment or question, I would request you to please raise hand or write in the chat box, please. And also in the YouTube chat box. So while that is coming, I can just ask Yashwant to perhaps give a little more elaboration on the idea of if I am an individual, I am either faculty in an Indian college or university, I'm interested in SKA, how can I get involved?
Yeah, so I think that's a good question to kick off a discussion. So as I mentioned that what we, when we set up the SK India Consortium, one of the main idea was this, that we should be able to provide the avenue for participation for people who are in different institutions. And so the way one would couple in would again depend a little bit on if it is just one sole individual in that university or institution, or is there a wider interest within the institution to be involved. So as I mentioned that for single individuals, there is scope to join as an associate member. and that we have had associate members. And sometimes what has happened is somebody joins as associate member and then they're able to come back after, I mean, they're able to have their institution join as a regular member after some time because they've been sort of making the case within the institution. And I think that's welcome and that's a good way to build it up. And once you join, either as an individual associate member or as an institution regular member, if it depends on what is it that you're interested in. As I mentioned, that we have these two different tracks, the science subcommittee and the technical subcommittee. The science subcommittee is well set up along the different lines of the science working groups, as well as promoting different aspects of the science in India. And so if you're interested in the science, which means either being able to contribute to the SKA science case from India, or being able to or wanting to use the existing facilities, be it in our country or outside, for for trying out some of the science ideas in building up towards SKA, then there is both the guidance and the providing, I mean, giving access to avenues whereby you can do this. For the technical activities also, again, there's a similar thing that you can then couple into any one of these ongoing technical activities, depending on what kind of interest and skill sets you bring to those activities. And a lot of that then works out based on the discussions that we have with the people who are joining the SKA India consortium. So I think this was, I guess, addressing to a virtual.
Yes.
So somebody has to say whether this was adequate of an answer or not, or are there follow-up lead questions from there? Yeah.
Many listeners are on YouTube, so may not get an immediate feedback.
Yeah.
But I think you made a clear point there. There is a question on the chat box, which I was going to come to next. That the question is about, does the individual association valid for undergraduates? As we know, in SKA India consortium at the moment, we have only permanent faculty members in different institutions as members, even associate members. So what program do we have in mind for students who might want to contribute? So Yashwant, you could answer, or I could even ask Teeth or someone else to get involved in answering this question.
Yeah, so maybe Teeth or somebody may want to take that up, but I think it's a good thing, it's a good question that we ought to think about if you want to sort of support young undergraduates, individuals. Is there some mechanism?
Yeah.
Teeth, go ahead.
Yeah, sorry, Dipankar. Okay, so we are basically the question was about there is some echo.
I think it's Dipankar, your laptop is producing the echo.
Yeah.
If you're not hearing, yeah.
So yeah, basically, how do the young undergraduates get involved in the SK? Of course, in the long term, the prospects are huge, as was also mentioned during the talks. The SK is a facility which is going to come up like a decade down the line. So people who are young want to get into this research field. I mean, the options are open for all of them. They should just make sure they get into topics which are related to the SK. They need not be only science topics in astrophysics and astronomy, but there are a lot of scopes in engineering and technical activities as well. In the short term, I mean, as of now, there are no formal programs from the SK project, which we will plan as the project final funding is sanctioned. But currently, I think the best option is to approach the SKA India Consortium institutes, the faculties working there, and get involved in short-term projects right away. That should give them a lot of exposure in what SKA is doing, and they can also contribute to building up of the SKA in some form or the other. These could be making theoretical models to building some small components of the instruments and work packages one is thinking about. So this is, I think, what the young students should look forward to. Any more details, they are welcome to get in touch with any of us at any stage.
Tirth, there is a question from Kaustubh Gupta. He says, for example, can we work on short-term or summer projects on science topics using the SKA?
Yes.
You want to answer that? Yeah.
Yes, of course. The short answer is yes. And I mean, obviously, yes. Except, as I said, we don't have a program which is completely dedicated to the SKA. But if you look at the SKA India Consortium institutions, a lot of them have summer projects, and there are faculties working on areas which are related to the SKA. So the best option would be to get involved in these summer projects, either through formal applications, or if the institutions kind of allow, you can just tie yourself up with one of the faculty members there and work on a short-term project, a summer project there. I mean, as I said, things would vary from institution to institution. And yes, so that would be a very good way of getting involved with the SKA-related science activities using short-term projects.
I just wanted to add that due to the COVID-19 pandemic, several of the student programs in the astronomy research institutions are at the moment either cancelled, summer programs are cancelled, or they are being suspended. So one hopes that the situation improves in the next few months so that all of these programs can be restarted, and then there will be a lot of opportunities in the SK India Consortium member institutions, of which there are now more than 20.
Dipankar, I think you are muted.
Yes, sorry, I had muted myself when Yogesh said there was an echo. So thank you, Tirth and Yogesh, both were very useful comments. There is a question from YouTube, I think, which Nirupam has picked and pasted here, and that says, it's from Sayan Basu. I assume India, being an associate member in the SKA, NCR is already involved in the science using the CAT7 data, MeerKAT data. So that actually did not require India to be an associate member of the SKA, but several groups in India are involved in science using MeerKAT. Tirth, would you like to comment on that as well?
Yes, I mean, if the question, okay, so I guess the question mentioned MeerKAT, but let me just generalize the question a bit and talk about whether Indian scientists are involved with the SK precursors, the instruments which are exactly there where SK will be built. And if you think of the precursors, then the two which come to mind immediately are the MeerKAT and the MWA. And I mean, it's a very happy situation for us that Indian scientists are very much involved in both of these instruments. I mean, they're really leading mega projects. I mean, I shouldn't say mega projects. They are really leading very science intensive and high resourceful projects using these two telescopes. So when I talk about Meerkat, the project which comes to my mind immediately is H1 survey being carried out by people in IUCAP, but also this involves people from other countries and other institutions as well. And for MWA, of course, the Raman Research Institute has been closely involved with various phases of the MWA. And also people in NCRA, I mean, working in solar physics and other areas are using MWA data routinely to do their science cases. So yes, so again, the answer is, yeah, Indian scientists are very much involved in the SKA precursors at this stage.
Yes, one should not forget that UGMRT is also one of the pathfinders.
Pathfinder, yeah.
And there are projects which involve the SKA precursors like Meerkat and UGMRT together. Like one of the things that has been sort of started is this thing called SuperMighty, where it's a large continuum survey over a large range of frequencies. So you have complementary frequencies between GMRT and Meerkat, and that is producing very interesting results as well.
Yeah, there is a YouTube question on from Shayan Basu. I think another aspect will be for students to get involved in interferometric imaging and identifying calibrator sources, which will be an important aspect in future for the SKA observations. So maybe Yashwant wants to answer that. I don't know.
No, I can take a stab at that. There's interesting questions coming from the youngsters on YouTube. That's good. So that's certainly true that as we go, the SKA imaging exercise will have its own series of challenges. And one of which will certainly be how you calibrate the instrument, especially SKA low. And even SK mid will have some challenges. And in that sense, learning how to do that with existing facilities is an interesting exercise. It needs to be seen as to how relevant one could make that by using the pathfinders for the actual full SKA, because some of the calibration challenges are quite different, especially for SKA low. But that's certainly a room for a lot of discussion there and thinking and planning.
All right. There is also scope, of course, for contributing in the technical activities in addition to science, and calibration is one such thing, but also towards contributing towards things in the construction phase. But, so are there any questions regarding that? So maybe I can phrase a question which might be in some people's mind, that if I am a technically capable entity, let's say I am a small industry, or I am an individual who has specialized knowledge, how do I know what opportunities exist for me for contributing towards the SK construction? So maybe Yashwant can.
Sorry, can you just you're asking that if
Yeah, so if I am, let's say, a small industry with some specialized expertise, or I'm an individual where I have some relevant expertise, how do I know what opportunities exist for me to contribute towards the SKA?
Yeah, so I think in some sense that is a bit of a parallel with what we discussed earlier about, and I would say certainly for individuals who have technical expertise and are wanting to contribute, the best thing would be to approach the SK India consortium, and then we can have that detailed discussion. For small industries, again, wanting to contribute, you can certainly still approach the consortium. The via media for how that would happen would need then to be discussed and seen. It would depend on the specific area of expertise and the kind of contribution. But we may be able to find a way of doing that because when we ourselves go in for the larger tenders or work orders, we may be having constraints on who we work with, how we work with, but it may be possible for subcontracts where somebody with a specific expertise or a smaller company with expertise can be coupled into the work.
Right. You mentioned this in your talk, but it might not have been very clear to everyone that there is a certain amount of fair work return for India, where there is a certain amount of assured in-kind contribution which is expected from among the funding that we will receive. However, there is also a fraction of the full SKA construction which is open for participation and bidding internationally. And so if any of our industrial partners wish to engage in that open area, do we have a mechanism by which we enable such participation? Prabhu, would you like to take that question?
Yeah, Deepankar, could you slightly rephrase that?
Sorry, I got disconnected for a while, but I don't know.
Yeah, so the question was that
in that question,
in addition to the in-country work that we will have out of our SKA participation itself, the in-kind contribution that India makes, there is also a pool of work which is available for participation by open bidding in the full SKA construction, which is actually a larger fraction of the work. So if any of our industries would like to take up that something from that bit of work, which is open, but we are ourselves not assigned to do that part of work, is there a mechanism for enabling our industries to participate in such activities?
So what the SKA has a concept of an industry liaison officer for each country, and we need to streamline that process, have a formal role and responsibility for industry liaison officer, whose one of the main goals would be this, that be able to be aware of what kind of central procurement activities are happening in the SKA, and that person would have access to that information. If if nothing else, there's certainly, I mean, that would be public information. It's just that you need to know when it's happening, and it would be a global public tender, and be able to, so that industry liaison officers should be able to both disseminate that information more efficiently within the country, as well as provide some guidance and tips for the Indian industries that are wanting to compete in that process. And so that is something that we probably need to work a bit more to set it up in a more organized fashion.
Right. Any more questions from YouTube or from among the people here?
No, Dipankar, I don't see any more question in the YouTube now.
Again, I think you touched upon this, Yashwant, in your talk a little bit, but maybe since there is time, you could say a bit more about what has been the Indian participation, Indian industry participation in the project already so far.
You mean what has been Indian industry participation?
Yes. Yes.
Yeah. So specifically in the SKA project, the maximum focus of Indian industry participation has been in the work that we did and have been continuing in the telescope manager, where we have participated with Indian industry partners for the design phase. In fact, even that I mentioned briefly, that concept design that we did in 2010-11 was also done in partnership with the industry members and also R&D groups of industry, R&D cells from industry, and that has proven very useful. And there is a good amount of that design work and followed up with this prototyping work that's going on, which is being done by the partners from industry. And that has actually been at the level where even the individuals from the industry are being then recognized by the SKA as valuable contributors. And that's like, well, we are able to identify who are the kind of workforce that would be needed for the construction phase. Of course, they have to come through the pre-qualification process and the rest of the thing. And so that has been a significant plus, because I don't think by ourselves, just from the resources from our own labs, we would have been able to make that amount of contribution. So, this point that was mentioned by Joe about the SAFE methodology, scale agile framework, and that is something which maybe we follow informally in our way, that you work for some time, then you find out what's the next most important thing and you do it. But industry has a very well organized way of how to deliver things in a safe, agile manner. And that, when it was introduced by the project office, and I think some of that probably even came from project office's interaction with Indian industries during visits over here, as to what are the best ideas or practices. We found that our industry partners said, yes, this is something that we are okay with. There's no problem in adopting to this methodology of delivering. And in fact, some of our own members from our research, from our labs, have got exposed to the process and have got trained in that process, and would be valuable members going forward during the construction phase. So in that sense, there has been quite a bit of contribution. And if you ask Prabhu, in the MWA phase, during which RRI built hardware for the MWA, there has been again a significant engagement with the industry to be able to build these things and contribute, without which anything which is beyond some scale of mass production really cannot be handled within our research labs and their resources. And the SKA will definitely, be at that scale where the industry has to contribute.
Yeah, I can request Prabhu to add to this with the hardware related contributions that have been made and are going to be made. Prabhu?
Oh, yeah, I was muted. Yeah, thanks. Actually, there are quite a bit of limitations that we as a scientific institute and a laboratory in a scientific institute has. For a sorry, I got muted. So for a design such as what we need for the SKA, especially in the digital boards and so on, we do have enormous amount of industry potential when they get actually connected with the scientific institutes such as what we did for the MWA work. We were able to build systems. For example, the system that we built for that are still operational in the MWA dataset for the last 7 years, no failure, no single failure. So we do have that industry capabilities. The industries participated from India, actually build the printed circuit boards and also assemble them. So we used a little bit of the laboratory capabilities to make these things happen. So these efforts are going to be hundreds of times, amplified when the SKA is actually going to be built with the Indian industry. So we do anticipate the industry capabilities are enhanced, and we know now better way to work with them, and we also know exactly where the further activities that the industries will be able to do it much more than what we did for MWA. So we anticipate this is going to be a very good success in the SKA building era, which is very soon from now.
Right. Thank you. So one of the things that we are going to have, we are planning in the SKA activities as a whole is, in addition to the contribution we directly make to the construction of the telescope and the observatory itself, we have a significant amount of activity inside the country, which includes the regional data center, as well as some in-country research and development. So, Yogesh, could you give a brief idea as to the scale of this activity, let's say about the data center that we are hoping to take up within the country?
Yes, thank you, Dipankar. The data products that will be produced by the SKA Observatory are what are referred to as standard data products, which will come out of the science data processing pipelines. But in order to convert these standardized data products into science, you need additional resources, both in terms of the kind of compute that you need to run on the data. Also, you need specialized resources to download those data. And all of this is envisaged to be done inside what are called SK regional centers. These centers will be distributed geographically across the globe. You saw slides from Phil and Joe that talked about that. And we are planning to locate one of the SK regional centers within India. It will be a very large effort on scales that we have never built in India before. So the idea, therefore, is to take baby steps first and try to build a prototype SK regional center over the next 4 or 5 years, gain experience. In the prototype data center, we envisage that we will use it, for example, for processing data from facilities that we already have access to, for example, the upgraded GMRT, or facilities in which our scientists are heavily involved in, like MWA or Meerkat and so on. Once we gain that experience, the idea is to scale out to much larger scales. So the numbers that we are talking about for the full SRC, which we will build after 2025, are of the order of something, data center that is able to ingest of the order of 100 petabytes of data every year. So it is going to grow within 10 years. It is going to grow to exabyte sizes in terms of the storage. In addition to that, we will also have commensurate compute so that the data that is sitting in the storage can be extracted and can be processed and can be converted into a form which is ready for science. And remember, we are not going to do this all in isolation. The data are going to be distributed over a worldwide global network of about, say, half a dozen regional centers. And we will provide users with a common portal so that they will be able to access these data sets in a completely transparent way. So for example, like if you want to check your Gmail, you just go to gmail.com. You don't have to worry about where exactly which server is serving your email to you. So the user experience, we hope, will be something similar to that, wherein the users will simply log into a common portal, and from there they will gain access to whatever data that they need or want. There will of course be authentication mechanisms to make sure that people only gain access to data sets that they're authorized to use. I think that's a quick summary. There will be a session tomorrow where we will talk for 1.5 hours on all of this.
That's right. Thank you. Because not everybody may come tomorrow. So it's, and also for people who will come tomorrow, having this prelude helps in tuning into the discussion more easily. So thank you very much. I think that's a very good summary. So there is one question, it's in two parts, from YouTube, from Kaustubh Gupta. And I think this is a perfect question for Tirth, if Tirth can see that. So how can SKA contribute to cosmology? And will SKIC provide opportunities for students interested in cosmology or in other topics outside of radio astronomy? The cosmology is not outside radio astronomy. Cosmology is very much addressed.
Yes, Deepankar. Yeah. I mean, radio astronomy has made tremendous contributions to cosmology. So that's something often is not appreciated, but this is something we can start with. Yes. So again, I mean, rather than going into details here, I mean, I would really urge you to take a look at the SKA international website and their science cases. There is a wide range of topics in cosmology which will be addressed by the Square Kilometer Array. This involves, for example, things like constraining the nature of dark energy, understanding dark matter, to probing the early universe with first stars, the evolution of galaxies throughout the universe, and so on. So the topics are wide ranged, and SK, I mean, in different wavebands are going to actually contribute to our knowledge in cosmology. And now, since we have, I hope we have been able to convince you that cosmology and radio astronomy are not too far apart. It's definitely possible to do SK related projects in cosmology, both short term and long term.
Thank you. I hope that addresses the question. We can't get immediate feedback, so but I think that was a good answer, Tirth. Thank you. Any other questions from anyone in Zoom? If not, we are coming close to the end of the session. So I think we have had a very nice wide-ranging discussion for the last 3 hours on various aspects of the SKA, both science as well as construction, Indian involvement, how Indian individuals and other entities can participate. And this is basically laying the ground for the full day workshop tomorrow, so that through these discussions, you absorb the preliminary information which is going to be useful in the discussions in all these aspects in more detail in tomorrow. So I would like to thank all the people who have contributed to today's discussions, the 3 speakers who started this session today so wonderfully, and all the moderators and everyone who has helped through this this session today. So I hope we will see all of you in the meeting tomorrow. Thank you very much. Over to you, Yogesh.
Before we close, I just wanted to make a couple of announcements. We start at 9:30 a.m. sharp tomorrow morning. So please be there. Just like today, we will be live streaming on YouTube the proceedings of the workshop tomorrow. And we will also be looking at questions that are posted in the YouTube comments. So those of you who are not formally registered members of the workshop, please do be sure to join on YouTube and feel free to ask your questions there. We've discovered this afternoon that there is at least one person who did not receive the link to the Zoom call for today, and presumably it was the same email that gave you the link for the Zoom call for tomorrow. So if any of you who are registered participants of the SKA workshop tomorrow have not received a Zoom link, then please send me an email. Okay, and if any of your friends have not received it, etc., please forward it to them, or just send me an email and I'll try to send it to you again. I think that's all from my side, and we are ready to close the meeting unless there's any last comment from someone.
No, I think so. Yogesh and everybody, thanks. That was, I think, a very good session. I was really encouraged to get so many questions, especially from what look like students and youngsters who are who have got access only via the YouTube streaming. Maybe we should give them Zoom access or something. But it's really nice to see that.
Yes, I also second that, and I think it was a very good discussion, particularly from the youngsters. So let's hope we'll get more and more youngsters involved in this activity in a more vigorous way.
Okay, so I think we are done. If we are done, we will close the meeting, and I request Shil Kumar to stop the live streaming as well.
Thank you very much. Bye, everybody. See you tomorrow.
See you tomorrow. Bye.
Yeah, bye. See you tomorrow.
All right then. Bye.
See you.